Okay, here we are for our second installment. We are now on microscopic properties of covalent compounds. So you've already filled in the ionic part of the table. Now you're filling in the covalent part, and it's set up to allow you to contrast the ionic and covalent properties to see how they're different. So the covalent compound forms when electrons are shared between two atoms, not transferred, but shared. And these pictures are the way that we try to indicate shared. So on the left side, you see two electrons with a circle around them. We're saying that those electrons are shared between the hydrogen and the fluorine. The straight line, the covalent bond, is also a way of saying shared. Covalent compounds form from all nonmetal atoms. So ionic was metal and nonmetal, but covalent, all nonmetal. And they're made from neutral atoms, not from ions. No one's getting a charge here because we're not transferring electrons, we're just sharing. Microscopic structure of covalent solids. So I have two different covalent compounds here. The one on the left is meant to represent carbon dioxide, and the one on the right is water. And of course, both of these substances can be solids. Solid carbon dioxide is dry ice. And what I'm trying to indicate here is, first of all, that we have individual molecules. We have water molecules on the right that are not bonded to other molecules. So the water molecules, there's covalent bonds inside holding the hydrogen and oxygen together to make the water molecule, but you don't then have ionic or covalent bonds holding that water molecule to another water molecule. Same with the carbon dioxide. The two oxygens and the carbon, those are covalently bonded together to form a molecule, but these molecules are not bonded to each other. So this is how it's different from ionic. From ionic, all of the ions are bonded to all of the other ions, and it's a continuous array. You don't have that with covalent solids. You have individual molecules that are not bonded to anything else. Now with the carbon dioxide, what I've tried to show is that they are just randomly arranged. So in the ionic, you had a very specific arrangement. It forms a crystal. It's a very organized, regular structure. You saw those salt crystals were all cubes, tiny little cubes, and the cubes just keep getting bigger and bigger. Very organized crystals. Well, with covalent solids, you can have crystals, sure, but you can also have what we call an amorphous solid. Amorphous means it's randomly organized. So the water molecules here are lined up nicely. They're organized so we can form ice crystals. With the carbon dioxide, we just get a little bit more randomness to it. You don't have to have a crystal structure. So giving you something to actually write down here, because I know I said a lot of things on the last slide, but nothing was written on it. Covalent solids are formed from individual separate molecules. We have covalent molecules. So we could say covalent compound, we could say covalent molecule. Those are used interchangeably, but we don't really apply the word molecule to ionic compounds because they don't form individual separate molecules. The atoms in the molecule are covalently bonded to each other, but they are not bonded to other molecules. So what actually forms the bond? It's still an attraction of positive to negative. It's always an attraction of positive to negative, but this time it's the attraction of the shared electrons to both of the nuclei, the two nuclei that are in the atoms that are in that bond. So this drawing is showing you how those shared electrons are being attracted to both nuclei and thus holding those nuclei close together. That's what forms the bond. Chemical formula for the compound is the exact number of atoms in the molecule. This is different than ionic because ionic is about a lowest whole number ratio. That's not what the formula means for a covalent one. It's telling you exactly what the atoms are and exactly how many there are. So H2O, for example, it literally means two hydrogens are bonded to one oxygen, and that's it, nothing else. There's no array here. There's no continuous array. It doesn't mean you really have millions of hydrogens and millions of oxygens. They're just in a 2-to-1 ratio. That's ionic. For covalent, literally, I have two hydrogens attached to one oxygen. That's it. Those three atoms are bonded to each other. They are not bonded to any other atoms. They form that one water molecule. And that's the end.